All right, today we are doing Unit 7A, Mission 2. For some reason it did not show up on here today. We are going to find first the theoretical probability, meaning what should happen. When we're looking at this grid, in class we're going to toss a ball against the wall and hit one of these squares. So in reality we need to figure out theoretically we need to figure out what happens, and then we're actually going to do an experiment and see, does what we think happened actually happen. So there are a total of, this square is 4 by 4, there's a total of 16 total squares. So the part we want is going to go on the top out of our total on the bottom. And right now we are looking for green. So there are 1, 2, 3, 4, 5, 6, 7, 8 green ones out of a total of 16 squares. So we can simplify that probability. I'm just going to move, this part down here. Is the part we want out of the total. That's how we write our probability. We can simplify this. Many of you already know this. We can divide by 8 to give us 1/2. So what's the theoretical probability of hitting a red square? There are 3, 4, 5, 6 red out of a total of same 16. And we can simplify this, divide by 2. Even numbers, we can write that as 3/8. I messed up here. It's asking us to write these as percents. So I'm going to go back and just write it as a percent. 1/2, if you plug into your calculator, 1 divided by 2 is 0.5 times 100. Remember, you're going from your fraction, you're dividing to get to your decimal, and then times 100 to get to your percent, which would be 50%. Red, we have 3/8. We're going to do 3 divided by 8, and then times 100. We get 37.5%. So 35.5% of the time we should land on red. And then our last section is blue, and there's only 2 blue out of 16. So we can simplify that or just plug it right in our calculator. It's really 1/8. And if we divide that in our calculator, we get 0.125 times 100, 12.5%. So 12.5% of the time we should land on blue. So most of the time we should land on green, then red, then blue. So in class, we're going to do an experiment. I'm going to give you some tallies of ones we've already done in the past. So there's not going to be 16 total tallies because there might be more than 16 kids who are throwing this at the wall. So when we did my experiment, I had 20 kids do this, and I had 1, 2, 3, 4, 5, 6, 7. Oops, I'm going to make my tallies underneath here. There's 5, 6, 7, 8, 9, 10, 11 kids landed on red. Green, we had 1, 2, 3, 4. I'm trying to look at my data here. It's all on one page. Blue, 2, 3. There was 2 more that had green. I missed those ones. So that should be 1, 2, 3, 4, 5, 6 people said green or hit green, and 3 hit blue. So we're going to write this as a fraction and then convert it to a percent. So here we had 11 out of a total of 20 people hit red. I did this experiment in class, so we're going to do this together. If you're not in class, that's why you're watching this video. 11 divided by 20 is 0.55, times 100 is 55%. So got close to what was expected, but it's not going to be exact because our experiment's not always going to be perfect. Green, we had 6 out of 20, which is 30%. Close, 37.5. And then blue, we had 3 out of 20 hit blue, which is 15%. Just so happened that these ones turned out to be nice numbers, whereas the ones over here we had a 0.5. So our experiment was close to reality, but not perfect. Next, they want us to figure out what's the probability, this time just as a fraction, of green, red, blue, not green, and not blue. We're going to take these one at a time. So this looks a little bit different because this square right here is really big. But when we talk about probability, we need them all to be the same size. All the squares or spinners or whatever we're talking about, all of the sections need to be the same size. So if they're not, we're going to make them all the same size. That's really 4 green ones of the smaller size. So how many total are there? Well, if we count them up, there's 4 here by 4 here. There's a total of 16. So the part we want out of the total, there's always going to be, oops, not 20, 16 on the bottom. So how many green ones are there? 1, 2, 3, 4, 5, 6, 7 green ones out of 20. How many red ones are there? 1, 2, 3, 4 red ones out of 20. We can simplify that by dividing by, we could divide by 2 or we could divide by 4 to get 1/5. How many blue sections are there? There are 1, 2, 3, 4, 5 blue sections. 5 out of, oh my gosh, you guys. I keep saying 20. I messed up. There's 16. Why did I think there's 20? 16. We got to go back and fix that. So we can still divide by 4, so it's not 1/5, it's 1/4. Our red. Going back to blue here, 1, 2, 3, 4, 5 are blue out of 16. Can't simplify that. How many are not green? So not green means how many are blue or red. So we're going to add those two together. So blue, there was 5, and red, there was 4. So total, how many are not green? 9 out of 16 are not green. And then how many are not blue? Well, other than blue, there's red and green. So there were 4 red and 7 green, which is a total of 11 out of 16 are not blue. All right, onto the back side. Same, but a little bit different. We need all of them the same size. So I'm going to make this green one, or section 2. I'm going to label them all with 2s, the same size, and same thing here. Those are all 3s. Now we're making them all the same size piece. So what's the probability of getting a 1? And they want us this time to write these as a decimal. So the 1s, we have 2 of those out of a total of, again, it's 4 by 4, 16 squares. So they want us to plug that in our calculator, write it as a decimal. 2 divided by 16 is 0.125. What's the probability of landing on a 2, or sections that are 2s? Here we have 1, 2, 3, 4, 5, 6 sections that are a 2. So there's 6 out of 16. If we divide that, we get 0.375. And then how many, what's the probability of landing on a 3? We have 1, 2, 3, 4, 5, 6, 7, 8 sections out of 16 that are a 3 or pink, which is 0.5. And the last part is asking us what's the probability of not getting a 2. So not getting a 2 would really mean landing on a 1 or a 3. So how many 1s are there? There were 2 1s, and there were 8 3s. So 10 out of 16 is not landing on a 2 as a decimal. That's 0.625. So they just wanted us to convert our fraction to a decimal this time. Last part, it's asking us to create a game board with the following probabilities. So notice we have 3 by 4s for a total of 12 squares. So that means all of our denominators should be a 12 because there's 12 pieces if they're all the same size. So we need to make sure all of our fractions have a denominator of 12 in order to color in the boxes. So to get to 12, 4 times 3 is 12. We're creating an equivalent fraction. 3 times 3 is 9. 4 times 3 is 12. So we're really going to have 9 red squares. Now we have the same denominator of 12 there. And 6, we need the same denominator. 6 times 2 would give us 12. That gives us 2 12ths. So we're going to have to color in 2 green squares. So you can put the letters red, blue, and green, R, B, and G, in the boxes. Does not matter what order you go in. If you want to go right across or right down the row, that's fine. I'm going to color in red. Oops, this is red. We have 9 that are going to be red. 1, 2, 3, 4, 5, 6, 7, 8, 9 red ones. You can put the letter R if you want there instead. And blue, we have 1 if you want to put the letter B, or color it in, it doesn't matter. And then green, we have 2 that are green. Oh, right there, 2. 1, 2. And if you want to put the letter G there for green, you can. There will be a couple questions on your homework like this that you do need to solve or color in. You can put the letters or use colored pencils or highlighters. So on your homework, the front is you creating your own game board. You get to color in, pick 4 colors, and then color any way you want. Then find the probability of each color. You will need to divide up these sections to make them all the same size. However, you need to color that section all the same color. And then on the back side, on number 4, I need you to cross off this row. This is not included. You should only have 6 squares for